Hey guys, this is Fred from Prettyfly Games, and this is episode 5 of how to build an online first-person shooting using Photon Fusion and Unity. So I've been getting a lot of requests on how to handle host migration. So in Photon Fusion we have this setup where we have a bunch of clients and one host. So if we connect with Eddie here first, he is going to be the host. The problem with Fusion is that if the host leaves, then the clients will not automatically take over unless we use the host migration feature. So let's join in with Teddy and Freddy here. So the host migration feature is a quite nice feature in Photon Fusion, but it's a little bit complicated to actually use. So in this episode we're going to focus on how to do that. So if we have Teddy here, we can shoot Teddy a little bit. Oops, we fell off the world. And then let's shoot him some more. So now we shot him a few times and we have Freddy. Let's disconnect our host. Then we will just continue. So if we shoot, well, Eddie is going to be removed because that's part of the host migration process. So he was reconnected but then left. So let's see where we have our dear Freddy or Eddie. So we shot him twice, which means that his actual values was copied from the previous host. So that's what we will cover today. So let's get started. So first of all, we need to activate the host migration feature. So let's go into the menu, Fusion, Network Project Config, and let's find the host migration and tick that box. Now the host migration snapshot interval decides how often the host should send snapshots to the clients so that they are getting all the data. Now 60 seconds in a first-person shooter is fairly long, so we're going to reduce that into 5. And you need to find the optimal level or the interval for your game. And this takes some performance, so you have to be careful not to have a too low interval, and the interval can't be too high either, because then it's going to look very weird if you jump back very far in the game. So be mindful of that. Then we need to start coding. So let's go into projects and let's go to network and spawner. Oops, I forgot to apply the settings. So we need to apply the settings before we do that. And let's open the spawner in Visual Studio. So in our spawner, let's scroll down until we find on host migration. So this is the event that will be called. And this is where we need to add our code. So first of all, let's just add it to our debug log so that we know that this has happened. And after that, we want, or actually the Fusion documentation states that you need to shut down the old runner and you need to start up a new one. There is no way to reuse an old runner. So we need to do that as the first step, shut down the old runner. So we do runner shutdown, and we can provide a shutdown reason, which is host migration. And this shows an error because the await can only be used in async methods, and this is not an async method. So we add the keyword async up here. Awesome. So that will shut down our current runner. But then we need to start a new runner, and that needs somehow to get the data from the old runner. And what we have is a host migration token that will be passed in this event. And the host migration token contains all the information required for us to start a new Fusion runner with the information about the old host. So we need to create a function to actually handle that. And we are going to do that in our network runner handler, so this one. But I already know what I want to pass in. What we need to pass in is, of course, the host migration token. So let's add a bit of code for that. So we are going to find the object of the type network runner handler in our scene, and then we're going to call a function that does not exist yet, called start host migration, and we'll pass in the host migration token. Alright, so let's save that and let's open the network runner handler. So we're going to reuse the code in our initialized network runner to do the same thing, but for the host migration. But before we do that, part of the code, we can reuse that. So let's create a iNetwork scene manager, or a function that will return an iNetwork scene manager, get scene manager, and it will be this part actually, so that we don't have to repeat it. And let's just do a return and scene manager. All right, so let's call this here. So we have our scene manager, and we can use get scene manager, and we have a runner. All right, so that will replace our the code for this, and we could actually use our whole task here to actually reinitialize our runner, but I will, for clarity, make another function of this so that we can go through the parts we actually no longer need, and we do need some extra parts. So let's copy that one, and let's rename that to initialize network runner host migration. And in this we can get rid of most of the parts, because we do not need all the information. So let's have we're gonna need the network runner that we will provide, and the host migration token that we received from the other function. And then this game mode, it will be in the token, so we can ignore that. And the same for address, we don't need that. And the scene will also be there, and the session as well. And the state is no longer required either. So we have our scene manager, and then we need some other parts, which is the host migration token. So let's add that. And then we will need our, we will need a function that when it has completed, then we need to do something else. So we have this host migration token. Now I copied the same code again, sorry. So we have a thing called host migration resume, which will call this function host migration resume, and which will be invoked when this is up and running. So we need to add a function for that. So let's add a host migration resume. Perfect. So that got rid of that error. Then we will take the code basically that we have in our start function, and we will create a new function for that. So let's add that after our get manager, or actually we can do it right here after the start. So this will be our public void start host migration. It takes in the host migration token, and it does the same thing as this really. It instantiates a network runner prefab. It will rename it to network runner migrated. It will start a client task, initialize network runner host migration, and provide the network runner and the host migration token. And then we will just write it to the debug log. So if we save this now and try it in Unity and see what happens. So I quickly compiled our client, so let's use that to join. So this will become the host, and then we can join with the editor and wait for it to, well, join. All right, awesome. Perfect. So now Fred is joined and we have our host Eddie. So let's leave with the host, and we can see that, okay, we have some things going on. So let's have a look at what happened. So we have our on host migration event that happened, and then we have our on shutdown because we shut down our runner, and then we started our host migration started, and well, then we haven't really coded anything, and then we have some problems after that. but that's fine. We can look at the problems later on. So now we know that our event is being triggered and that the host migration has started. So let's go back into our network runner handler again and have a look at the code there. So now that we have determined that we are getting the events, we need to start focusing on our actual host migration resume. So this code will be executed when we have started up our new runner. But here comes a bit of a problem. Since we have started a new runner, it means that everything that we had in the scene, all the players, are now gone. Because they only exists on the old server. So it means that we need to recreate all of our network objects. And what we can do is, based on the snapshot that we are getting from the old host, we can actually use those. So what we do is we run a for each loop. So our for each loop will get a resume snapshot network objects. So this will be a collection that we can run through for each with our resume network object, which is a network object, and run this loop. Now the objects that we are interested in are going to be the player objects, and they all have a network character controller prototype. So we can check that and say that, okay, we want to grab our network character controller prototypes. So we use try behavior, which returns true if it has found this, and it will set it as a variable called character controller. So if this code enters here, then we know that we actually have a network character controller prototype custom, and then we can start by copying some information. Or actually, when I think about it, before we start copying information, we need to make sure that we are creating them on the new host. So what we will do is we will spawn our objects, and we will also run some code. So what we have is runner. We're going to spawn an object, and we're going to spawn the resume network object that we are getting. We are setting the position of the character controller, and we're reading the position, and the same with the rotation, so that the object will start at the same position as the old one with the exact same rotation. And then we will run this on before spawned with our new network object. Actually, let's change the name to network object, so it becomes super clear what we have. So this is our Lambda code that will execute when we have spawned an object. So that's fine. And then we will take our spawned object, which will then be called new network object, and we want to copy the information from the old object to the new object. So what we do is our new network object, there is a function called copy state from, and then we copy it from the resume network object. So this means that the states are going to be copied, and then we need to end our lambda so it doesn't give us any errors. All right, so let's save this and try it in Unity and see what happens. So let's join with our precompiled client again, Teddy. He's going to be the host, and let's join with the editor. Awesome, we fell outside the world. All right, perfect. So we have Eddie here that we can shoot, and let's get rid of Eddie. So we will kill that client or the host. And as we can see, we have some weird stuff going on. So we have Freddy that is here, and we also have Teddy, which is the old host. He's over there, and well, we have a gun floating around. So let's look at what's going on here in our scene. So before we started, we had two network objects. So those have been migrated from the old host to the new host, and as we can see, the game is still running. So we have actually done our host migration. So that's the good part. The bad part is that, well, we have some weird things. So if we look at this player ID 4, player ID 5, we can see that they actually don't have any input authority, and that means that nobody is controlling them. And then we have 3 cameras in the scene, which is weird, we shouldn't have that. And we also have a network player, PF clone. And this network player is actually the one that we are controlling now. And we can see that because it has input authority. So we are in control of this player. So why is that? Well, it is because our game is not expecting to be started in this way. Because when we are reconnecting to the server and we are reinitializing all the objects, it means that some of the code is going to run multiple times. So we will get an extra client that we shouldn't have gotten, because our code is well written in a way that is not compatible with host migration. So we need to change that. And these 2 objects are actually the correct objects. It is the old host and it is the player we had before. So these are the ones that we should actually start to use. And one of them is going to be our old player. So we need to take control of that one. But first of all, we need to look at our code to understand why does this happen. So if we look at our on player joined, then we will see that we are checking if we are the server, and we are writing this, we are the server, spawning player, and then we are spawning a player. So the problem that we saw in the log is that from the host migration, we have already spawned the two players. And then when we are reconnecting, we do not understand that, okay, the host migration process has happened. But we are the server, so we are spawning another client. So that is why we are getting this third player in the scene. Now, to be able to solve that, we need to understand that this player is already existing in the game. So we need to figure out a way of identifying our old player and understanding that, okay, this is an old player, it already exists, we should actually take control of that player and not spawn a new player. So to solve this, Photon Fusion has a way of sending a connection token. So when a client is connecting, it is sending some unique number that we can use to identify the player. So if we go into our network runner handler, and if we scroll up to our initialized network runner, we can utilize this feature, and it's called a connection token. So let's add that to our code here, and we're going to say that, okay, we're going to send in a connection token, and it will be the variable connection token. Now a connection token is a byte array, so let's send that in after the game mode, and we're going to supply a connection token. The connection token is generated by the client, and it should be a unique value. So we need a way of constructing this byte array of a connection token, which also has to be a certain size. So the easiest way to do this is actually to use a GUID, because it will generate a unique combination that actually matches the size of this. But we need to convert it so we can actually start to use that. So let's save this and go into Unity. Now in one of the samples provided by Photon Fusion, they have a class that handles the transition from a GUID until a byte array. So I'm just going to steal that right away. So let's drag and drop their code for that. So they have a connection token utils. So let's open that and in Visual Studio and have a look at it. So it is a a class that sort of that looks like this. It's a connection token utils. It's a static. It has a bunch of static functions, and it can create a new token, which creates a new GUID, and then transfers it to a byte array. And then they have some ways of actually as well converting this information that we will utilize later on. So this is how it looks. The code will be provided in the project, but if you want to, well, type it by hand, this is how it looks. So our GUID that will be generated by this is something that we need to store and make sure that it's persistent over multiple clients. Because as we said before, the client will get destroyed, the runner will get destroyed, and we will reconnect to the server, and we need to know then that we have the same GUID so that we can identify ourselves against the server once more. So we need to create a new class. So let's go back into Unity. Then let's select scripts, create a new script, and we're going to call it Game Manager. So we're going to create a Game Manager now. And it will be a singleton that exists all the time. So it will be a perfect way for us to hold things like the player connection token and other things that we need to have, that needs to survive through scene changes and other things. And what we need a game object for this. So let's create an empty game object, call it Game Manager, and attach the Game Manager to it. I can't actually, because it hasn't compiled yet due to other errors. So let's hold on to actually do that until we have resolved the problems, but we can put it at 0, 0, 0 as a start. So if we look at the error that we have, it is in the network runner handler, and it's because we are not supplying this. So for now, let's just comment it out so that we can actually compile our script and get our game manager to work. Alright, so now we fixed that. So let's take our game manager, drag and drop the script there, and then we need to create a prefab from this. And we will do something special as well. We want to load our game manager as soon as the game starts up, and there's a little trick that we can do. Let's do a folder, resources, and in our resources, let's create a subfolder called instantiate on load. And our game manager, let's drag it there so it becomes a prefab, and then we can delete it. And then in our utils, let's actually create another script. So we will call it a startup script. So let's do create script startup, and let's open that in Visual Studio. So our startup script, it doesn't have to be a mono behavior. Let's remove that, and let's remove the start function. So what we will do, we will utilize a function in or a feature in Unity called the runtime initialize on load method. So anything in this under this will be executed before anything is loaded in Unity. So it's a perfect way of creating or instantiating things like game objects or game managers and other things that needs to exist in our scene before anything else. So it needs to be a static function, and we'll call it static initialize prefabs. And let's add some debug information so we know what's going on there. And what we will do is we will take all of our game objects that we have put in our initiate on load folder that is going to be in the resources. So we're loading all of the game objects, we're putting them into our array that we are calling prefabs to instantiate, and then we will run through all of them and instantiate them. So we'll do a for each loop, and we will write creating whatever its name is, and we will instantiate it. We actually don't need to write game object instantiate. we can just write instantiate, or actually maybe not. Let's keep game object. This will execute and it will instantiate all of our game objects that we put inside our instantiate on load folder, and that contains our game manager. So let's save that and let's go to our game manager. And our game manager, we want to make it into a singleton, so we will provide a static reference to itself, call it instance and set it to null. And I'm not going to go through how you make singletons. You can watch another video of that, so we're just going to make sure that it works. So in our awake function, we are checking if it's null, then it means that we have actually the first version of it, or the first instance of it, so it's going to be this. If it's not null, then there is already one, and we are just going to destroy it and return. And then we set do not destroy on load for this instance. So awesome. Then we have our singleton up and running, and it will be instantiated. So then we get to the part which we came here for, and that is our connection token. So let's add that as a variable, byte connection token. And so we want to be able to sort of generate it and to get it. So let's get rid of the update function and add our get and set method. So set connection token, and it's going to take in a byte and it's going to store it, and our get token is going to return it. Awesome. So now we can save that. So when we are starting our game manager, then we want to create our connection token. So let's check if it's null, because if it is, it means that we haven't actually created one. And yeah, let's change our code a little bit so it doesn't look that bad. All right. So then we are creating a new token if we don't have one. Awesome. And then we can go into our network runner handler, and let's remove uncomment the code we had. And in here we are going to add our instance, or actually game manager in instance get connection token. Whoop, there we go. Okay, so now that we are starting up, we are providing our network token in here. But we also have to use our token when we are reconnecting to the server. So we need to add this in our initialize network runner host migration. So we could add that as a parameter, but I'm going to be lazy and just add it directly here. So let's add connection token is equal to, and then we'll get it from our game manager. Awesome. So now if we go into our spawner, we can have a look at our code here. And what will happen is when on player is, we get this event on player joined, then we will get a player ref, and from this player ref we can actually get the connection token. So we can figure out if the player has been on the server or not before. But we need to add some more logic for that. So as before, we get the player ref here, but we don't know really which player it is, or actually which network game object it is. We only get the player ref. So we need to create that relationship. So let's create a dictionary where we will map this information out. So we will take a dictionary with an integer and a network player and call it map token ID with network player. So our GUID that we had created, we need to create or be able to turn that into an integer, and that's why we also started to using the utilities provided by Fusion already, so that the script that we imported earlier. But we want to make it easier for ourselves, so we're going to create a tiny get player token helper function. So let's get started with that one. And so it will take in our network runner and our player here, and it will decide first of all if we are the local player. So we're checking if our runner is the local player. If we are the local player, then we know that we can just use our get connection token from our game manager, and then we hash it into an integer and return it. Awesome. If we are not the local player, it means that we are a remote player. Then what we need to do is get it from our player ref. So there is a function for that in runner, get player connection token, and it passes in the player ref. So then we are getting our token here. And then we just need to check if it's null. It shouldn't really be, but if it is, something has gone wrong. If not, then we are going to hash it and return it. And if we actually have managed somehow to get a null value, then let's actually spit out let's upgrade it to an error. Get player token, return invalid token, and return 0. All right. Okay, so then when we have somebody join, let's add. Let's actually grab our player token. So let's get that when on player join happens. So we are getting the player token with get player token, providing the runner and the player. And let's actually change our debug log here so that we're writing it out. On player join, we are server connection token, and then we'll provide the connection token so we can see what is happening. After that, we do not always want to spawn a new player, because we want to be able to decide if this player already exists or not on our server. So what we do is we're going to check in our dictionary, and we are going to see if our token already exists. So we're going to do a map token ID with network player, try get value, try to use this integer and get out our network player. So if we do find a network player, it means that we already have an existing player. So we don't have to spawn a new player in that case. What we need to do is take over controls of it. So we want to give the ability for this player to control that object. So we will take our network player, and we will use get component, get its network object, and then use assign input authority to player, or with the player ref. So that way we will be able to control this player. And yeah, so what we might want to do in this case is as well, because we are no longer spawning a new player. That means that, or actually we are spawning a new player, but we have done it in another way. So we'll come into it later, never mind. So what we need to do is, in this case, we are no longer going to spawn a new player here, because we have already gotten one spawned when we did the host migration. So let's put an else clause in here, and if we couldn't find the player, then it means that we need to spawn a new player. So let's output that in our debug log, spawning new player for connection token player. Okay, perfect. So if we would run this code now in Unity, nothing much would change really, because we are never actually storing anything in this lookup. So it means that it will be sort of empty all the time. So we need to figure out how to store things within our map here. So what we're going to do is we're going to take our network player that we have spawned here from the runner, and we are going to act upon it. What we need is a way of storing this player token in this spawn network player. So we will use a network variable for that. So let's go into our network player, and we will add a public int in the top network. Where are we? String. All right, we can add it here. So it's going to be a remote client token hash, and it's going to just be called token, and it's an integer, and it's networked. Awesome. So when we have in our spawner, when we have received our token and we have hashed it, we can actually sign it, because we are the server. So it means that we can set network variables. Awesome. Then we also need to create this mapping in our dictionary. So let's do that. So our map token ID with network player, let's provide it with the player token, and then take our spawn network player and assign that in our dictionary here. But sadly, that does not solve our whole problem. So our server right now has an understanding of the client connection token and which network object it is. But this host that understands it will get destroyed when he is being disconnected. So we need to transfer this information into our new host. So that means that we need to be able to set some of this information. So let's make a simple setter function and make it public variable set connection token mapping that takes in an integer and a network player, and just writes it or adds it to this. Alrighty. So this needs to be used then when we are doing our server migration. And the server migration, it's done in our network runner handler. So let's go down there. So when we have gotten our network character prototype custom, then we know that we have spawned our runner here, and inside of this code we are going to map the connection token with the new network player. So we are using the try get behavior, getting the network player as old network player, and then we are storing the token for reconnection. So we're finding our spawner, we're using our function set connection token mapping with the old network player token and together with the new player, the new network player. Then actually I did forget something really important in this spawner, and that is we are using this dictionary and we haven't initialized it. So if we run any of this code where we're trying to read stuff from it, it's going to fail. So let's make sure that we are initializing it. So let's create an awake function for that, and let me fix that. And then let's make sure that we actually create it. Alright, so now we can save that. Then let's make our debugging a little bit easier by taking our connection token here, and let's add a player connection token. We'll write it to the debug log. Right. So let's save that and try it in Unity and see what happens. So let's try it with our compiled client, and we'll join as the host, and we'll start up our editor. So we have Teddy here as the host, and we have the other player as not being the host. Right, so Freddy is in there. We can shoot a little bit, and let's then disconnect the host. And now I can't move anymore, so that's a little bit weird. So it seems like it's not working, but it is actually working. So we can see now that, let's make it bigger. We actually have two networked objects, which is exactly what we had before the host left. So we have, these two. And one of them has input authority is not assigned, so that means that it was actually the old host. And the other one has input authority. So if we're looking in our logs here, we can see that, okay, we got our on host migration and we have on shutdown, and then host migration started, and some errors that there are 3 audio sources, but we can disregard that. And we can see that, okay, we are the server, connection token is this, and it actually found the old connection token. So it found ourselves and it assigned the controls to that player, which is this one. And then it continued with our scripts. So why can't I move? Well, that is fairly simple. And why has the camera not updated? So that's is the reason for this is that even though that we have assigned our input to it, we haven't actually changed our script to be able to handle this case. And as well, our camera here is not what we think it is, because it's a sort of a leftover camera from somewhere. And if we look at this camera, then we can actually see through the eyes of our player. So it means that we need to do some work with our camera scripts to be able to handle this. And these old cameras that are free floating here from, the old game objects, network game objects, they need to be removed. Okay, so let's tackle the problem with the free floating cameras first. So if we go into network and open our network player, then when we are starting up, we have our local camera handler. And if we open our local camera handler, pressing Control and clicking on it, then we can see when we are actually starting up, we are detaching ourselves from the parent. So that is creating the free floating camera, which is what we want when we are controlling the player. But the problem is when the player is being despawned, then actually our network player is getting destroyed. But since we have detached our camera, it won't get destroyed. So what we need to do is we need to understand that, okay, if we have gotten destroyed, then we need to act upon that. So we can do that by using the unity's on destroy. And then we check that, okay, let's say if we have a local camera. So if it's not null, then it means that we actually have one. And then we can destroy it when our network player has been destroyed. Okay, so that was an easy fix for that. The other issue isn't that complicated either, but we have to think a little bit what is happening. So we are getting this spawned is being called, and then we are checking if the object has input authority, and that's how we're deciding if it's the local player, and we're writing then spawned local player. If it's not, then it's this code that's being run. But the problem is when we are reconnecting the player after the host migration, then this object does not have input authority yet, because we are assigning it later on. So when this code is running, even if it's the local player, it doesn't have input authority. So we will always run this code. And the bad part with this code is that it cannot recover. So if it has decided that this person is going to be a remote player, then it can't change the cameras and all the settings into being a local player. So what we will do is once we actually have spawned and we have assigned our input authority, we're going to rerun this code again. But we're going to adjust the code so it can change between being sort of the local player with handling the camera and the remote player. So we need to make a few changes. So the first part is we're going to go into our local camera handler and we're going to remove this detached part. So we don't want the detached to happen here. And then we are going to change our local camera. We're going to make it public so we can access it from other places as well. All right, then we go back into our network player. Then we can also have another problem is that this code can throw an error. So we need to check that it is actually not null before we try to do that if we've done something with our main camera after the host migration. So let's make sure that it's not null before we try to disable it. Okay, awesome. So now we will move the code we moved from local camera. We're going to run it here instead. So as we are the sort of local player, then we want to enable our camera. Awesome. And as well, we want the UI to show up. So let's enable the UI as well. And then we need to detach ourselves. So we can detach our local camera from the parent. Perfect. And then we are sending our RPC, which is great. Then we need to look at this. Okay, so we are getting our local camera and we are saying that it's enabled or disabled. So which is correct, but we can use this instead. So let's copy this code and use that. So let's just see where we are. There we go. So disable the local camera. We are disabling the UI. Let's move that up so we see it. So if we think about the reconnect case again, it means that we're going to run this code first, which means that we are disabling the odd listener, but we are never enabling it again. So we need to make sure that we are running this code when we are becoming sort of the local player on a reconnect case. So let's do that before we actually detach our camera. So let's write enable one audio listener, and it should be enabled. And as we have disabled it down here in the reconnect case, it's actually going to be disabled when we come here. So get component in children will not work unless we specify that we need to use inactive object as well. So with this true, we include inactive objects. And actually, when I think about it, we forgot one change, so running this will not fix the entire issue. We need to look at our spawner because this code is not being rerun. So we need to run it again after we have assigned our input authority. So if we look at our spawner, then we have onPlayer joined, and after we have assigned input authority, then we can actually ask it to rerun our spawn code again. So we're gonna do network player spawned. So that will trigger this code to run again. Now we can save it and try it in Unity. So let's join with our Teddy and let's bring our client into the world, or our editor actually. Right, so we're running and we have joined it. All right, so here we are. We have Eddie here, and let's go up here so we know where we are at, and let's kill our host. All right, so now we have done our host transition, and well, we still have some errors. We can look at those later on. But we have our host migration started, resume started, we have spawned remote player, we have completed our host migration, and then we have onPlayer joined. We are the token, or we are the server with our token. We realize that we already have a player, and we are actually taking control over this player. So now we can continue, and this player is now our host. There are still a few cases to take care of. Like one of them is that this player, Teddy, is still in the world. And the reason why he is in the world is because, he got transitioned over when we migrated the host, but he never reconnected. So Fusion right now doesn't know what to do with it, because this player is not going to get a leave event because he hasn't left in this world. He left in the old world, but as he was copied from the old world into this world, it means that on this host he never left. So we need to add a check for this to make sure that players are reconnecting again to the new host, and if they are not, we need to get rid of them. So let's stop our client and let's do that. So to clean up the players that haven't reconnected, let's go into our spawner script, and let's add our own sort of fake event here, and we will call it on host migration cleanup. There we go. Well, where are we? Here we go. All right. So in this, first of all, let's add some debug information so we know that it's running and that it's gonna be completed eventually. So what we will do in this event is that when this is being called, we want to check, find all the players that has not reconnected. And for us, it's quite easy because if we look at our map between the token ID with the network player, then we can actually iterate through it. So we can go through all of that and check all of our network players in this. And what we do to iterate it is that we need to get the values for this. So we'll do a network object, and we'll call it network object in dictionary, and we'll get it through entry, value, get component, network object, because our network player contains a network object. And from our network object, we can check that if there is somebody controlling it. So if the input authority is none, then it means that nobody is controlling it. And in that case, we actually found one of the players that we want to get rid of. So what we will do is once we're going to write it to our debug log, and then we are going to despawn this player. And well, if you do it correctly, we should probably as well remove this from our dictionary so that the player cannot sort of reconnect, because that's going to cause some problems. But I will leave that as it is now, and that's homework for you guys. So if you are going to do it properly, then make sure that you're removing this from the dictionary. And then we need to call this function from somewhere, and the best place to do it is from the network handler. So when we have run through all of this, then we want to sort of start a timer and then do our cleanup. So what we will do is we will use a coroutine. So let's make a quick coroutine for this. So we do cleanup host migration. We wait for 5 seconds. You can select any value you want. 5 seconds might be long in your game, or it might be short, but we will have it at 5 seconds. And then we will find the spawner and call on host migration cleanup. And this is going to be started when we have performed our resume task. So another important factor when we are doing our host migration is that we need to copy all the data. So right now we are copying the sort of positions of the objects, but we don't care about which HP they had. So if a player has gotten shot and the host migration happens, then his health will be reset. So he will have a health 5 that a player starts with, instead of maybe 2 or 1 or whatever value he had. So we need to make sure that we are actually copying this information. So if we look at, we have our copy state from, which we will as well use for our information about HP. So let's add that. So we will copy information state, and we will take our network, resume network object. We will get the HP handler, and we will use it as old HP handler. And then we will get the new HP handler from the new player. Oh, it's not called new here. Let's change that to new network object. All right, and we get the component, and then we copy it. So This sounds very good and very promising. It means that we are actually copying the value, which is great, but our HP handler is a little bit special. So doing just this will not actually work. If we look at our HP handler, what will happen is that when we are looking into the start method, it will set the HP to starting HP. And when we are respawning this player after the host migration, this start code will actually run after that. So if we look at our network runner handler, this code is going to copy, and then it's going to be overwritten when we reach start. So that means that the player will still be revived and get 5 HP. So we need to control this by a flag. So let's add a public bool skip setting start values and set it to false. And so if we don't have skip setting values, then we need to read them or set them. Perfect. So now that we are respawning our player, if we look at our network runner handler, then after we have copied the information, let's go to a new HP and set skip values to true. So that way, when we are reaching our start function in our HP handler, then we will actually skip that part. So we will not read back the values. So then we are getting the correct synced values. So let's try that in Unity and see how it behaves. Alright, so let's do the join procedure. Alright, so I actually increased the cleanup for after the host migration, so we can see that the HP is working. So let's go to Teddy here and let's shoot him 4 times. 1, 2, 3, 4. So he has 1 in HP left. And let's do the host migration. Now it's done. And if I shoot him, he's dead. And then he has spawned here in the air. And when we are running the cleanup, he is disappearing because he didn't reconnect. So that's really good. But good is not perfect. So let's have a look at some other issues that we're having. So let's join with Teddy. And there is one, annoying thing still, and that is actually our camera. So if we're standing on top of this object here, and we are looking straight up into there, we're aiming at somebody that is, let's aim it against the sun, and then let's take our client and we kill it. So now our view is no longer looking at the sun. It reset. We're at the same position, but the camera has reset. So we need to have a look at our camera handler to see why that is happening. So let's go into our project and scripts and go into our local camera handler. So if we look at our local camera handler, when we are starting up, it looks all right, and then we are coming into our late update, and then we have this, which is setting the transform rotation of our camera. So if we were looking up before we actually had the host migration, as this is going to get reset, then it means that we are going to look at, the 0 values, because the camera rotation X is 0, camera rotation Y is 0, after we have respawned after the host migration. So we need to take these values and be able to store them. And what we can do is we can use our game manager to actually store these values. So let's go into our game manager, and I'm going to add a variable, and it's going to be a public vector2 camera view rotation. To make it a little bit faster, I'm not using a getter or setter method. You can do that on your own. So this is just to speed up this tutorial, which is becoming very long anyways. So we have our camera rotations here, and what we need to do is we need to actually copy the values we have from our game manager when we are starting up. So let's copy those values that we are getting from our game manager, but when we are getting destroyed, we need to make sure that we are storing them as well. So let's set those values when we get our onDestroy event, but this script is running on actually all clients, so let's make sure that we are actually the local camera. So in this case, we can't look at if the local camera is enabled, because when it's getting destroyed, it's going to be disabled. But what we can look at instead is if the rotation values x, y has not changed, then we don't care about it. So if they are changed, then it means that we actually have our local player, and those are the values that we want to save. Then we have one more thing that we have been sort of taking a shortcut on that doesn't work that great when we're doing local builds and testing this scenario, and that is the fact that we are using our nicknames is coming from player prefs, and it's getting it from well, the player prefs, which will be the same for all the clients on the same PC when we're testing. So it's a little bit hard to tell who is who when we're doing it this way. So let's become a little bit less lazy, and let's use our game manager as well for this. So we'll add a public, because we're still lazy, public string, and we'll call it player nickname, and it will be empty to start with. And if we look at our network player, yeah, then we'll game manager instance player nickname. Awesome. But we also need to set this in our menu. So let's find our script, UI main menu, UI handler, and let's not use our player prefs. So or we can actually use it to get this input field, but after we have saved it, we also need to inform the game manager that this is the name. So player nickname is going to be the input field text here as well. All right, so that's much better. So with that last change, let's try it again in Unity and see if it works better. So let's try our compiled clients. We'll join with Eddie, and yeah, there we go, and we'll join with Teddy. Awesome. Let's aim somewhere so that we remember where we're aiming, and then Freddy. And let's try to aim at well, where is it? The sun somewhere? Oh, never mind. Let's take let's aim over here. All right, and then let's shut down our host, and then we have reconnected. So now we can run around and shoot again, and well, Eddie was cleaned up there, and yeah, so the host migration has happened and it's working, and we can actually do it once more. Actually, this was probably the host, so it didn't have to migrate. And what you can do is add a few in-game messages to tell everybody that host migration has just happened. But now we have a pretty seamless way of handling host migration, and the game is well, stable and keeps on running with a new host. Host migration is a little bit complicated, and it requires you to test your code a lot. So when you're adding new features, don't forget to try host migration to see that it still works as it should. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. This concludes this episode, and I hope that you enjoyed it. If you did, please give it a thumbs up and hit that subscribe button and the bell to get a notification when the next video is out.